The oscilloscope that we'll be using is made by LabNation. It is an oscilloscope that can be connected to a mobile device. We'll be connecting ours to an Android tablet. I have two images of the LabNation oscilloscope. The bottom image is a top view showing the LabNation logo. The top image is taken from the right side. So where those two USB connectors are plugging in, it's on the right side. Let's take a look at the different types of connections that we find on the LabNation scope. The first connection we'll look at is the 5-volt power. On the top image you'll see a lightning bolt where the white mini USB is plugged in. You'll see that same mini USB on the bottom. You'll just need to plug that into a 5-volt source. The next connection is the data connection. On the top image you'll see the USB symbol with the blue micro USB plugged into it. That same micro USB is found on the bottom image. That will eventually connect to the tablet. There's one other connector that is involved to connect it to the tablet. We are using a 2-channel oscilloscope. That means that we can read two separate signals, with one with channel A and one with channel B. We'll primarily be using channel A. Connected to channel A is a BNC connector that allows us to connect the oscilloscope lead to the oscilloscope. That oscilloscope lead will go to the two ends that we connect to our electrical circuit. This is our oscilloscope lead or probe that we use to connect to the electrical circuit. This oscilloscope lead connects to our scope through the BNC connector. The black alligator clip is the ground, and the gray tip has a hook that comes out of it, and that is the power. If we zoom in on the probe, we will see this red switch. The red switch is meant to change the signal from 1 times to 10 times the signal. We were reading a very low signal. We might want to switch this to 10 times. If you're getting a value that you don't expect, make sure to check the probe red switch. On the tablet, we will be using a mini USB, a male one, to connect into the tablet. And on the other side, you'll find a full-size female USB. That connects to the data line coming from the scope. We are now ready to open the application found on the Android tablet. Turn on the Android tablet and click on SmartScope application. The LabNation logo should come up. This may take a little bit of time to load. Once the LabNation logo has disappeared, you will see a tutorial screen. Mine has already exited out of the tutorial screen, and we'll walk through some of the commands that you can perform on this tablet. There are 4 main areas of the screen. On the left, we will find the scope menu. The scope menu allows us to change from analog mode to digital mode. We can also do a mix mode and access the systems menu. On the far right is the measurements menu. The measurements menu allows us to add additional measurement values to the scope screen. In the very center, the graphed portion, is the scope screen. The scope screen is where we will see our digital signal. The bottom menu is the final section of the screen. The bottom menu has several commands. At the far left, the SmartScope logo allows me to open and close the left menu. On the far right, the ruler allows me to open and close the measurements menu. The USB signal, if it is green, indicates that the SmartScope has been connected to the tablet. If this is red, further diagnosis might need to be performed to make sure that the scope is communicating with the tablet. The middle sections allow us to stop, record, and take a screenshot of the signal. We can also change the modes where the rolling mode and arrow is located. There are several important things that we need to point out on our scope screen. So here we have an A that is green, indicating that is channel A, and on mine I have B, and it's not connected to the graph. You can hide or show A or B by selecting them and then selecting hide. The graph is set up in small increments and larger increments. So we have minor divisions, which are the small squares, and major divisions, which are the larger squares. The graph is set up to go from left to right is to change the time, and up and down is changes in voltage. So right now the menu selection item down at the right indicates that the major divisions are set to 200 milliseconds. We also see that the major divisions of the voltage range are set to 2 volts. I want to change one thing on my scope in the user interface. I think it looks better in a dark mode and it's easier to identify the signal. So if you would like to change, you're welcome to go to Systems, Color Scheme, and then select Dark Mode. Depending on the type of signal that we are trying to read, we may need to change the major divisions. There are 2 ways that we can change the major divisions. If you tap directly on the voltage value and then move your finger up or down, that will scroll through the options for a major division in voltage. You can do the same for major divisions in time. You can also use your fingers to pinch and zoom in both the time direction. So from left to right, pinch and zoom will increase and decrease the time. And from up and down, if you do a pinch, zoom, or pinch out, it will also increase or decrease the voltage major division. We have one more final item that we need to do in order to read our digital signal. If we take a jumper wire that has 2 male terminals and we plug one of the male terminals into the breakout board at the GPIO 18 physical pin 12, and we take another jumper wire and connect it at physical pin 20 ground, then we will take the ground clip found on the oscilloscope probe and connect it to the ground jumper wire. And then the gray probe, we will open it up and hook the other jumper wire coming from the physical pin number 12. Once I have that connected, I can begin to see a digital signal being displayed on my scope. The digital signal right now is using the auto triggering mode. Click on the auto triggering and change to rolling mode. If your signal doesn't look like mine, it's possible that your major divisions aren't set up correctly. Take the time to make the changes to your major divisions so that they match mine. I'm now going to switch back to auto triggering, and that will stabilize the digital signal and make it a little easier to see. The other option that you might have if you're not getting a good signal is selecting the Auto Arrange button. The Auto Arrange button analyzes the signal and tries to determine what the best major division settings are. Depending on the type of signal, sometimes Auto Arrange will do a good job of setting up the major divisions. We can see here that it did a terrible job. We can't see the major divisions because the voltage is set so low. In order to increase the major divisions for voltage, I will pinch my fingers together vertically in order to make changes to the voltage. Notice that we went from millivolts up to 5 volts. Because we know the signal is around 3 volts, we'll put it back on the 2 volt scale so that we can get a cleaner signal. You may have also noticed that I moved the A channel up and down by just using a single finger and dragging it up or down where I want the signal to be. We can do the same type of zooming with time. We just do it in the vertical direction. So we can either increase or decrease the amount of time that each major division is on the time scale. I'm going to change from rolling mode back into auto triggering in order to see the signal a little bit better. I can then click on the ruler on the right and the SmartScope logo to give an entire screen of the digital signal. I can get a little more data if I open up the measurement side. Scroll through the window using the arrows on the top. You want to ensure that you're in channel A prior to adding these additional data values. On the left side of each of these data values is a button that we can select to get the value. On the right side is a graph. We will be using the left data. There are other types of signals that could benefit from a graphed data. When I select the button on the left of the data value, I'm presented with that data on the main scope screen. Notice that we can see here that our frequency, as we would expect, is set to 1 Hertz or 1000 microhertz. It usually will give me the value, the mean, min, max, and standard deviation of that data value. Selecting the other data values will also give me information about them. I can select duty cycle, maximum voltage, mean voltage, minimum voltage, and peak to peak, which is a measurement between min and max. I'm given the value, mean, min, and max, and standard deviations of all those data values. This will be helpful in understanding this digital signal. Notice that our mean is at 1.56 volts. One other nice feature that this application has is I can select a voltage value on the screen. I simply just click on the area that I want to know what the voltage is, and I can move that up and down, and it will give me the voltage value. This can be handy when I have a signal that has multiple voltage values, and I'm trying to understand what the changes are as the signal changes over time. We will end this lab here now that we understand how to use a scope to measure and understand our digital signal. We will start the next lab by making changes to both the frequency and duty cycle, and then we'll see what it looks like on the multimeter compared to the scope.